Alright, so today I'll be talking about, I'll first explain some more about classes and inheritance, and then I'll go over new data structures if I have time. So let's briefly review on what we know about classes. So I'm going to create a class called animal. This animal class will have three methods. So we're going to have age, which will be an integer. It will be unsetted by default. We're going to have name, which will be a string, weight and height in inches, and yeah, I'll keep it at this for now. Alright, so we're going to have a constructor. We're going to first have an empty constructor. We're also going to have a constructor that just takes in an age and a name. And we're going to have a constructor that takes in all four parameters. Let me zoom out. And then we're going to assign each value through the constructor to the class. And we're going to do the same for our first constructor. And we're going to assign for the default one a default constructor or a default name and age. So this dot age is equal to a random age. Let's just make it random, and I'll teach you guys how to do that later. So, but for now, I'm just going to put 0. And this dot name, let's just set it to hello or standard or no name given. So we have three constructors. These constructors are default methods run by Java on a creation of an object. Let's also add some methods. Of course, if we create a class, an animal, dog is equal to new animal, like this, we can run different methods through the constructor because this parentheses technically acts as a function. And we have three constructor options right here for us. We can provide nothing, an age and a name, an age, a name, a width, and a weight and a height. And so let's just do the third one for now. So an age, a name, hold on, let me zoom out. A weight, let's just say 120, and a height in inches. So let's just say he's, wait, hold on. I don't even know how much a dog is supposed to weigh. 80, and height, just say 12 inches tall? I don't know. So, we can access these parameters as so, like that. But what if we made these private? Which is what you should be doing because it's good practice for coding. Then we don't have access to like the variables that we want to use. So instead we can use a method called getters and setters, and we've already done this, but these are basically functions that will return each input value. So for age, we want to write a function that gets the age. So our return type will be an integer because we're returning an age. Get age as our name, and no parameters because we're taking in nothing, and brackets. So we want to return this dot age. This refers to this class that we're working with. So I'm actually in IntelliJ, there's an auto generate getters and setters, so I'm going to do that right now. But otherwise, you would type out all these by hand if you don't have it. But oh wait, yeah, I'm going to first demonstrate how to do a setter. So to set an age using a method, when it's private, it's going to be a void return type. Wait, hold on. Because we're not returning anything, we're just setting something. And we need a parameter to find the new age value. So I'm just going to call this new age. This dot age is equal to the new age. Like so. And so now I'm going to generate getters and setters. So generate getters and setters for all three of these. Oh, what do I do? Okay. Setters and okay, so now all the getters and setters methods have been updated. Now I'm going to think of another method that we could use through an animal. We can have it public void print out stats, which just gives in a report, gives in a report on the animal. So we can print out like a fancy report section. So I'm going to do that right now. All right, that's finished. So yeah, this is our current animal constructor. I mean, not constructor, class. So we can create an animal like this, and then we can assign it to we can assign it different values by using a setter, and we can retrieve different values by using a getter. And the reason why we can't access the variable by itself, it's because it's private. So we need getters and setters to help access and set the variables. It's private because we want to, well, I mean, it's good coding practice, so just make variables private for now. Now, let's just say I have a I have a house of dogs, and I know that they're all dogs, but they're not animals, they're dogs. So how would I create a dog class with that still has all these attributes, but has like a couple more only for dogs? So how I would do that is use inheritance. Create a new class dog, and then we're going to make it so that this inherits all attributes from animals, or the class animal. And the way we do that is write extends. Extends means that it is a part of animals. It's like a child of animals. A class can only extend one class. So you can't have extends animal and let's just say I create like human or something. You can only extend one class. After this, it, inheritance occurs, so it basically has all of these like methods and variables, but we can't see them because yeah. So like if I were to create a new constructor, I could still access get age, get height, get name, get weight because they're still a part of the animal class. But notice how I cannot access this, like weight, name, age, height. It's because this is private. So I must use the getters and setters. So we have a constructor called dog, and let's just say that all dogs are 8 years old. All dogs are 8 years old. So that means I don't need a height parameter. I only need an age, a name, and a weight because all dogs are. Wait, no, I don't need an age parameter because all dogs are 8 years old. So all I need is weight and height. So now I could theoretically assign set age to age, set height to height, and everything else. But I can also call this constructor, and we do that by using the function that's pre-written in Java called super. This function, much like this, like the keyword this, refers to the parent class. So I could do super dot all of these, like age, yeah, and stuff. So super dot, to call a constructor the super class constructor, you just need to put two parentheses around it like you're calling the constructor. And so we're going to reference this constructor right here. So we know the age, which is 8. We know the name, which is name. We know the weight, which is weight, and the height. And we're only going to include one constructor for dog. What else does a dog do? Uh, well, we can also put another string method, favorite dog food. And again, generate getters and setters for this dog food. Hold on. Getter and setter. Now, in the report, it's not including the favorite dog food. So we need a way to override the original class's printout stats with our own. And there's a way we do that. We're going to first create an annotation. So to do that, we type in an at, and this specific annotation is called override. And so anything beneath this function is an override of the superclass function, the superclass being the one that extends off of or animal. So the superclass extends, the superclass contains a method called Printout Stats. So we're just going to copy this method, and now we have a Printout Stats method that overrides this. So whenever we create, let's just say we create a dog. Well, let me do dog.printout_stats. Oh, wait, this is a function, not a string. Okay, so now we have dog true dog, which is another class that we create, equals new dog. And since the only constructor for this is name, weight, height, we're just going to do Perry's brother, weight 80, height 9. Alright, so now in the printout stats function, this line will call this function, while this line will call this function. And in this function, we're actually going to copy and paste this, because all we need to add is, wait, hold on, get name, get age, get weight, get height. And all we need to add here is favorite food. Favorite, or get favorite dog food, or favorite dog food works because favorite dog food is in our class. So, yeah, that's basically inheritance, and I could run the code to see if it works. Yep, see, the animal only has four default stats, while the dog, which we extend or it off of, has 5. Or we didn't include favorite dog food, so let's just do that. String favorite dog food, and then we can assign favorite dog food to favorite dog food. So now in our constructor, we have to include the favorite dog food. So now if we run it, it should work. Yep, that's how inheritance works, and that's pretty much the basics of it. You can find more about inheritance online. It's a pretty advanced topic, and most CSA classes, which is a high school class for computer science for advanced students, won't cover inheritance until like the very last month of it. So yeah, I'll try to go over inheritance in a later video, but yeah, that's all I can cover today. And we're gonna talk about. I think we'll only get to Arraylist today, and I'll cover the rest next video. So Arraylist is a data structure similar to an array but more powerful. So first, let's talk time complexity. So it time complexity won't really matter now, but it will matter later on, and I'm only going to go over it briefly. So time complexity is how fast your program will run. So let me give it an example. If I had this one uh, snippet of code, uh, 1, 3 plus 5, how fast will this run? Almost instantly. If I compile, it will automatically run. Okay, so we call this O of 1, written in this format. It's constant time. It Your computer only has to calculate one calculation. What if our program consisted of this? This would also be an O of 1 because it would technically be 3 times 1 because we have 3, but we drop the constant in most cases. Sometimes you could still include the constant, but technically this would be O of 1. O of 1 runs pretty much instantly, and yeah. Now, let's talk about another case called O of n. This is called linear time, so let me write up the code. Alright, this is O of n time. It's called linear time, and it's because the computer is calculating all iterations from 0 to 15. So n in this case would be uh the length of the for loop, which is 15, because we're iterating from 0 to 15. I mean 14, which is 15 numbers. So n refers n refers to the length of the for loop. Linear time. So I could have this, and this would be O of n. Now, if I have two arrays, I mean two for loops like this would also be O of n because it would be O of 2n technically, and we drop the constant. Next, and O of n is still a really good time complexity to have, and your program should usually run in O of n. 3 is O of n squared. This is if I have a for loop nested into a for loop. Or I have to use E or J. Now, so for 1,000 times, it's calculating 1,000 occurrences. So we're calculating 1,000 times 1,000 total iterations. So this is known as quadratic time, or O of n squared. And it could continue to O of n cubed if I put another for loop in here. And it could continue again. So yeah, the larger it gets, the worse, the slower your program is going to run. So that's a bit about time complexity. Okay, and now I'm going to go over an array list very briefly. So if you don't know how to do arrays yet, or like if you're not fluent with arrays, I strongly suggest you brush up on arrays because they're really useful for Java, and you'll be seeing them like for the rest of your coding career if you choose to do one. So we learned that an array is a data structure that can hold multiple of that same data type. So an int array of what can hold like 1, 2, 3, 4, 5. Note how we can only access and change values, and also we can grab the length. Array of 2 points to 3 because it's 0 indexed. Array of 3 points to 4 because it's 1 indexed. 0 indexed. Array of 5 will give us an error because there is no array of 5. Alright, we can also assign values to positions. Array of 2 is equal to 2, so now this position would become 2. Array of 5 would equal to 2 would not append another element to the array. It would just give you an error because you can't access this variable. Okay, now contrast to arrays, we can use an array list, which is a more advanced version of array. So I'm going to type this out first, and note that you will have to import java.util.arraylist. Actually, just import java.util.star, which means everything. Arraylist called arraylist equals new arraylist. Notice how we're also using a constructor function because it is a pre-written library. Now what goes in here? This is the type of the array list. Like for here, we initialized our type right here, and for the array list, we would initialize our type right here. Now, much like an array, it holds a variety of objects. We can append an object by using add to the array list. We can remove an object by using the remove. It removes index 0 as shown. We can also grab an element by using get. We can insert or not array list. We can insert. Can we insert? Oh yeah, it's add. So another function or version of add is we could do insert element 3 into index 1, and we can do a lot more operations. Size returns a size. Clear completely clears the array. And the most useful is contains, which checks if an element is present in the array. Unlike, it can do all of this, which is better than an array. So yeah, I'll talk about this later, but this is the basics of an array list. I would strongly recommend using it over an array if you need to do like very advanced programming. And similarly to an array, to iterate through all values of an array list using a for each loop, we would just write for integer, because we're counting integer elements in the array list, print out the elements as so. So yeah, that's it. Next time I'll talk about other data structures such as Arraylist, and I'll talk about how this relates to time complexity.